Take a moment to look around you. Can you spot one item made of plastic? We are drowning in a material culture of plastic dependency in which every year 380 million tons of plastics are produced and 8 million tons are released into the oceans. Although plastics take more than 400 years to decompose, 83% of all plastic packaging goes into landfills, of which households are responsible for 80% of the waste. It leads to microplastics in food chain,
threatening wildlife, being ingested by species,
killing marine life,
filling up landfills,
polluting the land,
clogging drains, causing flooding. It's simply too overwhelming for us four to start tackling on our own. So we've decided to start small, by beginning our journey with a cucumber. We thought, instead of starting with a sheet of plastic, what if we could package the cucumbers with a dippable bio-based solution that dries into a thin protective film? Currently in Finland and in many other countries, cucumbers are shrink-wrapped in plastic before being transported and sold. This method involves temporarily heating a plastic film to around 180 degrees Celsius before covering the surface of the cucumbers with it. Not only does this method contribute to huge amounts of plastic waste, but it also requires extensive machinery and production of heat. But the thing is, packaging is not just negative. Studies have shown that shrink-wrapped cucumbers last 3 times more than an unwrapped one and will only lose 1.5% of their weight after 2 weeks compared to an unwrapped one with 3.5%. And so our quest for a bio-based dippable packaging solution began.
Developing our quick drying liquid packaging solution was not an easy task, and it was challenging to find similar projects and prior research to guide us. In the lab, we decided to take our first step with agar, which is a commercially available non-toxic substance. It can, for example, be used as a gelling agent in the food industry or solidifying agent in bacterial cultures. When the cucumbers were dipped in the agar solution, we achieved satisfactory results, as we managed to obtain a glossy, transparent protective film. What's more, the film could be easily peeled off and then disposed of in the biowaste. However, how can we make sure that the packaging is able to withstand the varying humidity of the atmosphere? Therefore, we added a small volume of dispersed carnauba wax solution in the agar solution to create a more hydrophobic film, and we noticed that the film formation remained quick. In addition to our work in the laboratory, we found one research article of interest. In this research, the ability of gelatin-containing cellulose nanocrystals to extend the shelf life of strawberries was studied. The authors came to the conclusion that the mixture was effective for protecting fresh strawberries during the storage period. Based on these studies, CNC was added in the agar wax solution in order to extend the freshness of the cucumber. During the experiments, other cellulose-based materials were also tested for off-film, such as CMC and MCC. However, most led to a thick gel texture, weak bonds, or slow film formation. Upon numerous experiments, we were able to create the optimal dip solution composition of 2.2% agar, 0.1% CNC, and 0.03% wax in water. With this solution maintained at a temperature of 45 degrees Celsius, we managed to obtain a solid film formation in 17 seconds. This is how our new liquid packaging solution, DipWrap, was born.
DipWrap is a liquid packaging solution that forms a biodegradable, non-toxic and visually appealing film that can be easily peeled off. In the first 24 hours or so, the film acts as an aqueous environment and shock-absorbing layer during transportation. Also, CNC can act as an efficient antimicrobial agent, making the film ideal for preserving fresh products. All properties that cannot be achieved with a conventional shrink-wrapped packaging. This product is designed to be applied at an industrial scale, but targeting 3 sub-levels. The industrial level with its efficiency and fast solid film forming time of 17 seconds, the commercial level with its longer shelf life, and the consumer level with its easy removal design and biodegradability. When envisioning our product at an industrial scale, this packaging liquid has to be heated only to 50 degrees Celsius and mixed gently in order to avoid solidifying. These conditions are mild in comparison with industrial production lines in general. As CNC is a relatively new material, we must work in parallel with the current pioneers of research in nanoscience to ensure its full safety. One main issue is the costs of our product. Agar and CNC are expensive compared to polyethylene used for shrink wrapping. This will inevitably affect the price of packaging of cucumbers in the beginning. However, when oil prices keep on rising and when the growing sell rate of the DipWrap enables cheaper production of CNC, it could possibly reach a wide sphere of consumers in the future, and not only the climate-conscious population. We have also been researching more efficient and environmentally friendly substitutes for agar-agar, as well as carnauba wax. These alternative ingredients ensure DipWrap's positive impact on the environment and the people, so that the ingredients used would not cause, for instance, eutrophication through overharvesting of seaweed.
Our goal is for eco-friendly packaging to be more accessible around the globe. Not only does our product reaffirm the recent trends in environmentally conscious consumption habits, but it also allows the current research being done on eco-packaging to be accessible at a wider level by interweaving into the consumer's everyday lifestyles.
Unlike shrink wrapping, DipWrap can also be used at small-scale local farms without extensive machinery, which allows for packaging solutions for local farmers to promote local food production. The dipping solution could also be used for other vegetables and fruits to prolong their shelf lives, berries being one of the foods with the shortest lifespan. The prolonged shelf life would decrease food waste, which is another major environmental concern. The global pandemic has not only confirmed the devastating human effects on the environment, but has also sharply raised the hygiene standards. Cellulose-based packaging materials would be one of the keys to working alongside the world's development and circumstances. The world is trying to reduce single-use plastics through creating global efforts such as United Nations Sustainable Development Goals and EU's limiting of plastic products. One method of limiting some single-use plastics will be through consumer awareness and new labeling requirements. Our product fully supports this directive as it provides a novel alternative for single-use plastic item. DipWrap, with its unique liquid application, contributes to raising awareness of the issue beyond to cultures where the negative consequences of plastic packaging are not yet widely acknowledged.
Working on this project together has sparked fresh design ideas of approaching the same issue. What if we could innovate even more ways to use DipWrap? Could the material be collected and reused instead of recycled as biowaste? Could DipWrap be sprayed instead of dipped? What if the packaging could also be used to seal a half-cut cucumber? We find so much inspiration from the everyday and infinite potentials of this product.
For us at Cumber Inc., our goal is to make sustainable packaging the new standard for the 21st century.
We would like to encourage the industry, as well as the consumers, to be conscious of their everyday choices, and to encourage people in their community to do the same.
We want to create a new market for eco-friendly products and packaging and inspire other companies to follow in our footsteps.
DipWrap might be the first baby step, but all changes must start somewhere small. So let's all take a small step together today for a better tomorrow.